Hi, welcome to lecture 2.5 of the SAGE-based course on Monte Carlo Methods. We were looking at collections and covered lists in example 1. In example 2, we will look at sets from the point of view of collections. So we declared sets and operated with sets earlier. Sets are another SAGE collection. Remember that in a set, each element has to be unique. We can specify a set directly or make one out of a list. So in the first line here, L6 is a list starting from 100 and ending before 200 in increments of 5. And now S is a new variable and it's being assigned set of L6. So we made a list L6 in the previous line, and now we are assigning the set of L6 to the variable S. And now we ask S to be displayed, and S is now the set containing this list. So it's actually now S is now a set. Sets are unordered collections. Okay, so this makes sense when you think about what we know about sets. What matters about a set is that the elements in it are unique. Okay, so there is no sense of ordering in a set, unlike the sense of ordering in a list. The set 1, 2, 3 is the same as the set 1, 3, 2, and it's the same as the set 2, 3, 1, etc. This means that it makes no sense to ask SAGE what's at some particular position in a set as we could with lists. Lists are sequences and order matters. Sets are unordered, so order makes no sense for a set. We cannot use the index operator with a set. This will give you an error message. If we ask what's the first element in index position 0 of the set S, it says set object does not support indexing. Right. Now in example 3, we will look at dictionaries. Okay, this is how we actually encoded functions or maps as a set of ordered pairs earlier. Now you're just learning that dictionary is another type of collection. A SAGE dictionary gives you a way of mapping from a key to a value. As we said earlier, the keys have to be unique, only one for one of each key, but more than one key can map to the same value. Right? You remember the father's map? Now let's redo that. Find father's map is again Jenny Jonathan, Kathy Jonathan, Anu Raz, and Ashu Raz. And now we simply ask it to display find father's map, as we did earlier. Now if you ask what's the type of find father's map, it says the type is dictionary. Okay? When we make a dictionary, we tell SAGE that it is a dictionary by using the curly braces, okay, and by giving each key value pair the format key:value. So a dictionary is something like the indexing operator we used for lists, but instead of specifying the position we want, we simply specify the key we want, and SAGE returns the value that the key maps to. So that's what we did with find father's map of Anu. We simply pass in the key and ask what is its value, and SAGE says its value is Raz. So it's a good time to pause the video and go through these U-tries carefully and get the syntax of working with dictionaries under your belt. In the next video, we will cover our next major conceptual topic, which is probability.